Okay, now we're going to start 7.2. Again, we're going to use the Henry's quiz grades from 7.1. All right, the first thing we want to do is a box and whisker plot. A box and whisker plot uses 5 numbers to generate the graph, okay? And those 5 numbers are the high, the third quartile, the second quartile, the first quartile, and the low. Okay? The high is, of course, the highest value in the list. The low is, of course, the lowest value in the list. Those are fairly easy. Most people get those. The high is highest value, and the low is the lowest value. So again, if we use Henry's quiz grades, then the low is 30 and the high is 98. Now I am going to use, this is the ordered list that we did in 7.1, back on page 4 of 7.1. Back on page 4 of 7.1. Okay, let me see if I can expand this out just a little bit and see if you can read it still. Okay, so maybe that's a little better. Okay. We found Q2 is the median. So that is the exact middle of the list, and we found that the median was an 86. Okay, we found that back in 7.1. Back on page 4, we found that the median was an 86, and that is the middle. Now, going back to our list, we know that there are 50 data values, and that 25 and 26, so the split is right there. So the upper half of the list is from 98 to 86. The lower half of the list is from 86 to 30. Now, Q3 is the median of the upper half. Okay, in our case, so we have 25 data values there. Half of 25 is 12.5, or the 13th value will give us the median, because that is the one that there are exactly 12 on one side and 12 on the other, and then there's one lone value in the middle, and that's the 13th value. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 94 is the median. Yeah, I'm sorry, 94 is the median of the upper half. So it is Q3. So this is 94. Q1 is the median of the lower half of the list. Again, there are 25 values in the lower half, so we're going to count and find the 13th value from the 86 that starts Q2, or we could find the 13th value from 30, whichever you want. Let's go from 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 80... Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I get 81. So somewhere there's a mistake here. It should be 81. It should be the 81. I could have copied the list down wrong. So 81 is the median of the lower half of the list is 81, okay? Now, we're going to use these 5 data values to do our box and whisker plot. And I'm going to do it, I just flipped over the back of my ordered list, and I'm going to do it here just because I don't have enough room on the paper. And in the notes, it's a separate page. So this is Henry's quiz grades. Title. I have a vertical bar that is my scale. And I started with 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, perfect, 100, and these are the grades. Now, what you do is I'm using a ruler, and I use a ruler just to help make it straight. So, our high is a 98, so I'm going to go right here, and I'm going to just draw a pencil bar so that I know where it is. Our low is a 30. Again, I'm just drawing a pencil. Our Q, I'm going to move this so I can try to see the values. So we have high is 98, Q3 is 94, Q2 is 86, Q1 is 81, and the low is 30. Okay? Now, I should say this. When you're finding Q2 and Q3, okay, when you're finding Q2 and Q3, if the median is an exact value in the list, so to find our median, we averaged two numbers together and then found the median. If the median is an exact number in the list, like say that my data value were only the upper half, so my median then is 94, okay? Then when I go to find Q1 and Q3, I do not include the median. I do include it here because the total list is an even number of values. If it's an odd value, if the total list is an odd number, I do not include my median. So I'm going to draw lines at 94, at 86, and at 81. And this is called a box and whisker. So what we do is we draw a box that, think about this, okay, look at this. We're going to draw a box around our quartiles with a line at our Q2, and then we're going to have whiskers going out to our high and our low. So that's kind of giving you a little representation of what it's going to look like. So we're going to draw a box with a line with our Q2, and we're going to draw whiskers going to our high and our low. So that's what a box and whisker looks like. So now I'm going to show you the one that I did that's in your notes. Okay, so let me show you this. Okay, so here's our box and whisker, and the reason I'm doing this is because this is a little neater. Make sure you note, this is 50% of the data is from the high to the median, and 50% of the data is from the median to the low, okay? And 25% of the data is from the high to Q3, from Q3 to Q2, from Q2 to Q1, and from Q1 to the low. Okay? Now, typically I would erase the lines so that they're not there. What do we see? We note that the 50% that I've told you, what do we notice from the graph? We notice that 30 is an outlier. It tells us that the upper 75% of the data, right? 50, 25, 75% of the data is clustered together. Okay? We notice that 50% of the data, the middle 50% of the data is relatively equally spread out. And that the bottom 25% of the data is very spread out, whereas the middle 50% is fairly equally spread out, but this one is wide. Okay, this is not uniform. whereas this is uniform, if that makes sense. All right. Please email if you have any questions. These box and whisker graphs, you will have, these are how they send you the data for standardized tests, and you will have to look over those box and whisker graphs for standardized tests and for dealing with standardized tests. Okay, next we're going to talk about the interquartile range is Q3, so this is the IQR, is Q3 minus Q1. This is another measurement of dispersion that we talked about. It's another way to tell us how big that box is. The line graph depicting a normal curve is a bell-shaped curve. This is the what we really want. It goes back to those to the bell-shaped curve that we'll have. We'll see it again in a minute. Okay, so it goes back to this. This is a bell shape. And this is kind of what we want. Even in our box and whisker, we're kind of going to want this type of look. We're going to want everything to be kind of uniform. All right, next we're going to talk about standard deviation. Okay, standard deviation is the average distance that a value is from the mean. It is the square distance from the mean. So remember, the distance, if I look at just a regular distance formula, then I have two values, the measurement between two values, plus a measurement between the y values. I square each of those, then I take the square root of the sum. So for standard deviation, what we're doing is we're going to use that second value as the mean. So we're going to take the distance from the mean, so x1 minus the mean and squared, x2 minus the mean and squared, and sum this up for all the x values and divide it by n, so we find the average, then take the square root. What the standard deviation tells us is it tells us what is the distance between data values. So if I have a standard deviation of 6, that means that about all the data values are about 6 units apart from each other. Okay? Not really, it's an average. Remember, average means that if all things are equal, that's where what everybody gets. So for standard deviations, if all things were equal, then everything would be about 6 units from the mean. Would be about 6 units from each other. So the question is, how do we calculate this? Well, I'm only going to use, so we're going to go back and we're going to use our data, but I'm only going to use the first column because it is a lot of work to do the whole list. So we're going to have xi, that's our x value. We're going to find xi minus x bar, so xi minus our mean. Then we're going to square that value, xi minus x bar squared. Okay, total. So our first value is 85. Our second value is 97. Our third value is 58, 82, 81. We found that our mean was 80.6. Okay, now I'm finding the mean of just these 5 numbers. Okay, this is the mean of just these 5 numbers. So that's 403 divided by 5. Okay, because I'm only finding the standard deviation of those 5 numbers, not the entire list. So what you're going to want to do, and I'm going to use a TI calculator just because that's what I have easily available. So you're going to turn it on, get out to the main page, clear everything out. So our first value is 85 minus our mean is 80.6. Okay, enter. So that value is 4.4. So this is 4.4. Then we square it. So I'm going to hit the x squared key. And that value is 19.36. Okay, and I work my way across. So next I'm going to do 97 minus 80.6, 16.4, squared, and I get 268.96. Now, if I keep going, okay, you're going to keep going, so you're going to keep filling in all these values. And if I keep going, then what I get are these values right here. 510.78, 1.96, 0.16, okay? Then what you do after that is you sum up all these values. Remember, I wanted to find the, what was it? X1 minus the mean, x2 squared, x2 minus the mean squared, and then I sum all those up. So I'm going to sum it all up, and I get 801.2, and then I divide by n, which is 5, because I only have 5 data values, okay? And I get 160.24. This value is actually called the variance. Okay, that value is actually called the variance. Then to find the standard deviation, you take the square root, and you get that the standard deviation is 12.65859. So I'm going to show you 106.24, and I want to take the square root of that, so I actually have to do second square root, and I can't find it. There it is. And I want that answer, so I'm going to do second, and then the plus minus key gives me that answer, and I'm going to hit enter, and that tells me the square root. So once I found the sum, then I take the square root of it. Okay, and that is a standard deviation, and it tells us how spread out the data is. Okay, next we're going to talk about normal curves and the 68, 95, 99 rule. What this means is that 68% of the data is within one standard deviation of the mean. 95% of the data is within 2 standard deviations of the mean. And 99.8% of the data is within 3 standard deviations of the mean. So if I know my mean, I can find that 1 standard deviation is going to be, I add the standard deviation to it, and that'll tell me. And it will be only 1 standard deviation. If I go 1 positive standard deviation, I only go 34%. If I want to find on each side of the mean, I look at each of these. Okay. Next, we're going to talk about scatter plots. Scatter plot is just plotting x and y. So we're going to remember these as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is basically just doing an XY curve, you know, normal XY plots. And so we've already done that. So I'm going to show you what the scatter plot looks like. You go to 1, you go up to 26, you put a dot. The difference between a scatter plot and a line graph. The line graph has the values connected. Remember back when we did the line graph that we had the values, we had lines connecting the values. So this was the line graph, okay? So we had lines connecting each point. For a scatter plot, we do not put those lines in there. Now, a line graph can be used to represent you're going to have numerical things, but you could have quantities on your, in a line graph, in a line graph, your x-axis is time, always time. In a scatter plot, your x and y could be quantities. So if I want to compare a bat's forearm length to their wingspan, I can do that in a scatter plot, not a line graph. Line graphs are really commonly used in charting stocks and bonds and that sort of stuff. Scatter plots are used in charting test scores and versus attendance and things like that. Sample is part of a population. Sample size is the number of values in the sample. Margin of error is the error from calculations. Everything has a margin of error. Okay, we always if you're measuring something, you have margins of errors. Weighted average is something like GPA. It's where you have a weight on your averages. Okay, and we'll calculate some weighted averages in a few minutes. It's most things have weighted averages. And I'm going to stop this now because this has been 20 minutes, so this is talking through the notes. And then I will record and pick up the next lecture will be me working through the example.